Hello everyone, welcome to the final project presentation by Group 5 with Xinghang Chen, Tianhao Hou, Frank Li, and Tianyuan Cai. Our research project mainly aims to maximize the profit of a food truck company located in a mid-sized city in the US, whose main business is making and selling fast food products, including burgers, sandwiches, and nuggets. We addressed this blending problem by constructing a linear optimization model which generates an optimal weekly production plan, balancing among 20 products in 4 categories that require different combinations of 16 kinds of raw materials. The project calls for considerations on both the financial benefit and manufacturing cost of each product, bounded by the upper limit of each particular raw material's quantity of supply, as well as a weekly total purchase budget of $8,500. Taking the nature of fast food business into account, we also estimated our expected business volume and plan not to oversupply the potential demand for each product in order to avoid food spoilage or wastage. With regard to our data sources, we mainly took realistic data and information from our major competitor in the industry, McDonald's, as reference, including menu and price, product ingredients, sales revenue, and number of stores, etc. We then furthered our research by performing a sensitivity analysis after the optimal solution was generated, which gives us more insights on how the solution changes when we change the coefficients of the model. That is to say, interpretation on sensitivity report outputs provides us more valuable information concerning product pricing and data evidence for other business decision-making. Then let's welcome my teammate Xinghang to elaborate on our model construction process and mathematical formulation.
For the model part, we refer to McDonald's most popular items for the selection of our products to sell. There are 20 variables that are included in 4 categories, which are chicken, sandwich and wrap, breakfast, and beef. The 20 variables are McChicken, New Caesar McWrap with crispy chicken, Egg McMuffin, and Big Mac, and so on. These 20 products require 16 kinds of raw materials, including beef patty, crispy chicken portion, regular bun, sauce, and other 12 materials. You can find all the information in our report and Excel. We assign coefficients to all materials required in the production of each item. For instance, a McChicken consists of 1 unit of chicken patty, 2 units of lettuce, 2 units of burger buns, and 1 unit of sauce. According to the 2020 QSR Magazine report, in 2019, McDonald's reported $40,430 million in sales, and it has 13,846 units in the United States. After calculation, we get that it gains $8,000 per unit a day. Comparatively, as an independent store with limited productivity and customer flow, we used $3,000 as a reasonable prediction for our daily revenue. Applied with normal distribution, we used VLOOKUP and rand function to get the simulation of demand for each week. We assume all the raw materials are purchased on a weekly basis, given the nature of fast food business. After estimating the demand for each item, multiplied with the coefficients of their raw material used, we made a weekly raw material purchase budget of $8,500. For the mathematical formulation, with the aim of maximizing the profit of 20 products for each week, we multiply the price and quantity of each product and add them up to get the objective function. There are 3 kinds of constraints. One is the ingredients quantity of supply constraint. The use of each raw material cannot exceed the quantity purchased based on demand estimation per week. For example, beef patties constraint is 1x16 plus 1x70 plus 2x18 plus 1x19 plus 2x20. It should not greater than 1,000. The second one is the supply constraint. The quantity of each product sold cannot exceed the maximum quantity we can supply. For instance, number of McChicken sold for each week should not be less than or equal 364. The last one is the constraint of budget that ensures the money we use to purchase raw material doesn't exceed our budgeting amount. Next, let's have Frank to introduce the results of our project.
And for the result part, the prescriptive analysis generates insightful information. First of all, it calculates the optimal solutions that maximize revenue by changing the variables. And every variable represents the number of products we should make every week. Specifically, we should make, for example, 0 McChicken, 38 Junior Chicken, etc. Some products' optimal producing number is 0. We could fix this inefficient problem in the next producing period by either adjusting demand expectation or cutting off some products. The sensitivity analysis also makes useful information. Allowable increase and allowable decrease are the most important columns. According to those two columns, we can see how much objective coefficient can decrease or increase without changing the optimal solution. In this case, it means we can see how much more expensive or less expensive one product gets before the optimal solution changes. It provides valuable information to help us adjusting the price in the future. In constraint table, shadow price is the most important column. It shows the change in the optimal revenue value with one kind of a material increase by 1 unit. We notice many material has 0 shadow price, including fish patty, sausage patty, etc. We think this reason is demand is limiting us from producing more. Even if we get more materials, we could not producing more products because we don't want the production to surpass the demand. The evidence supporting our deduction is many materials' final value is lower than the constraint of the right-hand side. Finally, the simulation page provides us a tool to simulate demands in the future. Then we can change our producing accordingly. Next, introducing my partner Theo to talking about the conclusion.
Thanks, Frank. In this model, based on the sales and the relevant data, we produce the product's demand and use normal distribution to simulate the demand variation and diverse product on a weekly basis. We believe if it's possible to have access to detailed single items specified sales and demand figures from McDonald's will make this analysis more accurate and precise. In terms of satisfying demand, not all the needs were satisfied. We consider that it is more in line with the idea of truck management. The truck will be closed if all the inventory ingredients are gone. For the parts that are not satisfied, we suggest that you can serve customer better in the coming week by increasing the ingredient limit and increasing the total purchase amount together. Alternatively, we could ditch those low margin products for high margin products. We have set some materials for infinity, which shows 10,000 in Excel. They are less sensitive to fresh requirement and are easier to store. Unfortunately, we miss the fact of how to store those inventories in such small space like a food truck. If the model is used in the future course, we hope you can add the inventory turnover cost in the section as a possible storage cost. We also brainstorm some ideas which may apply to future project extension. If our company owns 2 or more food trucks, and those trucks are selling a variety of food like Chinese, Mexican, how to meet people's needs based on the district ethnicity distribution, you may conduct a research based on the district distribution in Greater DC area. That's pretty much of our project. We hope you like it, and we hope it may be used in the future course. Thank you for your time and listening.